All right, everyone. Welcome to today's live stream. Today, we're going to be taking a look at continuing to look at malicious Office documents. In particular, we're going to be focusing on Excel documents, and probably the most notable change in the use of those over the last couple of years has been a heavier reliance on Excel for macros. So, if you're not sure what those are, then you've come to the right place. We'll talk about those today. If you missed the last stream, it wasn't from last week; it was 2 weeks ago. We started a discussion about malicious Office documents focused on Word documents and really just the sort of the standard VBA, the Visual Basic for Application style macros that those contain. So again, that's something that's a little bit different here with these Excel docs that we'll take a look at. So let's see. I'm going to make sure I've got the chat open. And yeah, so let's just go ahead and get started. If you have any questions, anything you'd like me to explain or maybe try to dive into a little bit, please feel free to just drop a message in the chat. If Let's see if there's any issues with the streaming. I think last time I had a couple users report that the stream to LinkedIn was frozen. So hopefully that's not an issue. If it is, unfortunately, on the platform you're at, I am multi-streaming to multiple platforms. So LinkedIn, Twitter, and YouTube. YouTube probably would be the best or the most reliable. I'm not 100% sure on that, but certainly if you find that there are any issues with the streams, the stream that you're on, the platform that you're on, please just consider checking out a different one. This will also be recorded, so you'll be able to find this video on YouTube once we wrap up here today. As I was getting into grabbing some example documents for today, I had originally planned on just taking a half hour or so to go through one or two. Of course, the more I dig, the more interesting things I find. So the longer the session will probably get. So I'm still aiming for about an hour, maybe a little bit less, just to give you an idea. And then, of course, depending on any discussion or anything there. Okay, well, let's jump right into it then. I'm going to share my screen. Oh, Apple. Every time I share my screen, it takes the wrong desktop. Here I thought I had it all figured out today. So let's see here. We're going to go ahead and start with a couple of example documents. And you'll see I'm in Remnix. I've talked about Remnix now in previous live streams, so it shouldn't be anything really new there. Here's a link just in case anyone is interested in getting a copy of that. Nothing really special about this version of Remnix I'm using. I didn't need to install anything additional. The only thing I do before any demonstration, and really almost every time before I start using it, is just to make sure that I have it updated. So I go ahead and just run the Remnix update, Remnix upgrade commands, and you can check all that out in the official documentation. Now, with our documents, we have 3 documents I want to look at today. The first one is just, I named these in order, Demo 1, Demo 2, Demo 3, just to help myself keep things in order. Looking at that with file gives me an opportunity just to confirm the type of artifact that I'm dealing with. And that's oftentimes the first step, using something like file to see what is this? Is it an Office document? If it is, is it Excel? Is it Word? Maybe it's a different type. Maybe it's a PowerShell script or an executable. So just a standard sort of kind of sanity check here to make sure I am analyzing the right thing. Of course, as you start to utilize different tools then in your sequence of analysis, your workflow, if you somehow misidentified a file, then likely one of your tools will break. So with this particular file, it's an Excel document. Oftentimes, go to OLE dump in order to see if it has macros, so VBA style macros. In this case, there isn't. And keep in mind, too, I think I mention this every time, there may be a faster way to analyze this. You may come across an Excel document and decide the quickest thing to do is to upload that to a until I just lost my train of thought. It's been one of those weeks, boy, let me tell you. There might be a quicker way. So we might, come across a malicious Office document. You might decide to, upload it to a sandbox and watch the behavior. Oftentimes, that is something I do as well. Upload it to a sandbox, whether it's something that you have on-prem or it's a private, private solution that you're using or one of the many public sandboxes that are out there, just to get an idea of the type of the functionality, maybe some of the process activity. If it launches PowerShell, then I'm looking probably for PowerShell in these documents, the network connections that it's making, just other important behavioral characteristics. And that might be enough. You might not need to analyze the document any further. But the focus here is getting into the documents and understanding a little bit better their structure, so that when you do need to analyze them, the tools, you have a better understanding of how to do that. So that's really the focus today. um, Now there's a number of things we can do from here. Let's do we're going to use OLE dump, and I'm going to change a couple of, going back in my command history, because I don't trust my memory to type these things out. So I'm going to change the file. And then we're going to use the plugin BIF, which is a plugin provided with OLE dump, and the plugin options. I've noticed in my usage of these different plugins, if you need help with the commands, you can replace that -X that we had previously there with the -H, and that'll give you specific help options for that particular plugin. So that can be quite helpful. Um, in this case, though, I'm going to use -X. So if you go back and look at that output, that help output, you can see what -X represents. What I'm using this for is just to see the structure of this particular document. And in this case, I'm mainly focused on identifying the fact that it does have some multiple sheets, and that some of these sheets contain Excel form macros. So you can see the visibility. As we'll discuss today, the visibility of a sheet is going to be either visible, hidden, or very hidden. And there's some kind of quirkiness to some of the visibility settings. And then this kind of the overview with these Excel form macros is that the executable content, the macro content, then is actually stored in the cells in these sheets, and the auto open function, or however the document is deciding to execute those macros, it's just going to start executing that content through the macro cells. Now you'll see in a moment the obfuscation gets very fragmented, and that's what makes the tools like we're using here really helpful in trying to unravel these. So with this particular doc, we have several sheets. There's usually at least one that's visible. That's going to contain your template, your lure, your social engineering image, and then possibly a number of hidden sheets that just are going to have all of our functionality, maybe some resources, string resources, for example, spread out. So we have identified those. We've identified the visibility. Usually, and I might not even use the plugin if I don't see VBA macros. Might turn right to the XLM deobfuscator, and that's another. So that's one of the problems that you'll have, or one of the tools that you can just oftentimes go to. And if it finds Excel form macros, it's going to go ahead and try to decode those for you. So you'll see here with Remnix, it's just XLM deobfuscator, not XML. So just make sure you get that right, and -F, and then the file. So now we can run that. And if everything goes well, we will have our output. We'll have actual content here that is the emulation of those cells, so we can see the functionality. It also tells us where it began, so it identified the auto open, not only the sheet but also the cell, just in case we wanted to actually look in those sheets and do a little bit of tracing inside of the Office suite. Um, we have now the functionality, and in this case, because this is an Excel document, it's likely initial delivery, it's likely trying to download next stages. Then really what we're probably going to find, what we're focused on, is just uncovering what those next stage URLs are. So this first one, you can see it's been more or less decoded if it was not obfuscated. Some of these later ones just have real basic string manipulation. There's just some, it's just being broken up and kind of concatenated back together. So what we could do, just to make that a little bit easier to view, is just replace our ampersand double quote with nothing using sed. Oh, what did I forget to do? See, use the wrong. Plus, I meant to pipe that, and I hit a /. Yes. Now what did I do? forgot that forward slash. Try that again. All right. So that was supposed to be a quick way to clean that up. I managed to turn that into something a little bit more painful. But now you can see that that obfuscation's been removed, and now we have all of these URLs. So again, it's fairly common to find in these documents, these downloaders, a number of URLs that we can then extract. Yes, thank you, Bob, for pointing that out. If we move over to, so the other VM that I'll be using here is my Flare VM. And I forgot to show this earlier, but just in case you want to get your hands on the sample, there's the first Excel document that we're looking at. You can find that on Triage if you'd like to download it. It's probably in other places, but that's where I grabbed it from. We can go to, the reason I'm using this Flare VM is just because I have the Office suite installed. So I still have an old Office 2010 installer that I got years ago. So I typically use that, and it works pretty good for me. Although I have had occasion to use the more recent versions of the Office suite, and it seems to work well. Whatever's available to you. In this case, we don't really need the Office suite. I just wanted to open up this document. And here you can see that we have our standard enable content message. So it knows that there's macros. It hasn't executed those yet. If we scroll up, you can see I've already had that open. So I was scrolled off the screen. We can have this image. In this case, I think this is an emotet, and it just uses a very simple image here. If we right click, you can see we have this option to unhide. And we can unhide these sheets. There's probably a quicker way to do this, but I don't remember, or I don't know off the top of my head. So I'm just going to unhide all of them in sequence. All right, and now we have all the sheets. Again, you start to see evidence of strings or resources that are available. Here's our URLs. They're just content embedded in the cells. And in this case, we have a number of characters that are broken up, and likely what's happening is there is commands that are grabbing each one of those values, concatenating that back together. It turns into something that is the next step of execution, and then it's going to execute that. We could just type in auto open here. That'll take us to the auto open sheet and cell, and then this just begins. If there's nothing in that cell, it just begins to drop down and execute until it encounters something. So here we eventually get to column B, row 5, column B, and now we have our first formula. And again, you can see just by visually inspecting that, it's painful. Nothing jumps out to me as an obvious, this is what this is trying to do, other than grab those values and sort of pull things together. So being able to, utilize a tool like XLM Deobfuscator is, can be an incredibly useful, a big win, because it took all of that obfuscation that we just saw and turned it into something that is, very, very much easier to read and to analyze. Okay, so that's the first sample. Let's take a look at the second. So I'll get this caption up a little bit sooner. Another Excel document, of course. You can find that on Triage. I really need to do file, but go ahead and do that. Now, I've gotten questions over the course of the last few months, especially some of these sessions with the file extensions. File extensions are a bit superficial. I tend to give anything that I'm analyzing, a .bin extension or something that if I were accidentally to double click on it, or I'm messing around in a terminal or a command prompt, I don't want that to execute. Not such a big deal on a Linux host. I don't think LibreOffice is installed. So if I double click this Excel, if LibreOffice or OpenOffice is installed, it'll open it. I don't think it'll execute the macros. I've never really messed around with it too much on the Linux side of things. But if I'm analyzing things on a Windows host, then adding that extension just helps to prevent simple things like double clicking it on the desktop as you saw I did with this one, and just preventing that from opening. Excel documents also, you have to enable content, so you've got this additional barrier that sort of helps prevent that. But try to just get into a good habit, or at least I do, because I've gotten careless in the past and had some almost disastrous consequences with some ransomware. Okay, so we'll take a look at this document, and the only reason I wanted to bring this one up is to let me find the command. No, that's not what I want. There we go. We're gonna use the plugin BIF again, and what we're looking at, this is another Excel XLM macro enabled document. And what we're using the plugin BIF to do is to look at this visibility. You'll see that we have a visible sheet and then we have a very hidden sheet. So the very hidden sheet is one that, if we go over to Windows, there's our document. I'll open that up and move the formula bar, right click down on the Sheets tab. You'll see I can't unhide. There's not an option to unhide. So Microsoft, at least through the Office suite, is not allowing us the ability to unhide that particular sheet if we wanted to view it here. Now, if we go back to Remnix, let's try the XLM deobfuscator. See, there was an unexpected error here. That it's actually been a problem with this document for a year or so. I suppose I should submit a bug, but I just haven't gotten around to it. It doesn't really change the analysis here in the demo. My point is that you can see it is in fact still able to access that macro content and do the emulation. The visibility, I don't suspect anyway, is having an issue with, is causing an issue with this. To be able to actually emulate the macros. We'll unhide that sheet in a minute. You can run that unhidden version through XLM deobfuscator. You'll run into the same problem. This one's an interesting document because it does a little bit more with some anti-analysis. You'll see the use of this reg.exe and some comparisons to the results. So there's a little bit more anti-analysis with this particular document. If you are interested, let me see. I think I have this as a here. You can check out, there is I have just a small number of exercises. I've been meaning to get more and more up. I wanted to do once a month. Obviously, that was a daydream. But this particular document is part of one of the exercises I posted on my GitHub. And what you can find, or what you'll find here, is it's sample 2. There's a number of analysis objectives to include dealing with the visibility of this sheet, just so you're aware of it. And you can also find this as a CTF on Cyber Defenders, as well as a full solution or walkthrough. So I won't go through all of it here because hopefully there's a pretty good solution available on this GitHub if you want to check that out. Okay, so if we want to change the visibility, I think there's a handful of ways to do that. One way that I have found that works well is I'm going to change my command. We're still using the plugin BIF plugin with OLE dump. The option that I'm changing is to use this -o bound sheet -a. And what this is giving us is information about essentially header information. I forget exactly the description from the plugin, but what we're seeing then is information about those sheets. And in particular, if you look at the first 1, 2, 3, 4, 5 bytes, we can open this document in a hex editor and modify the visibility. So you have on Remnix the WX hex editor. I had a couple files in here, so let me close that just so I don't confuse myself. So here's our demo 2 file. So here's the Office document that we've been investigating. And if we go to find, we can search for this hex pattern. So 3AD9010002. That's all I did was type that in. And now we need to Oh, I must have changed it. Let's do this. Okay, so I just did an undo with my clipboard because I think I changed it as I was preparing for this demo. Just forgot to change it back. Yeah, that's all I did. So there it is. So now we use that plugin from OLE dump in order to identify this sequence of bytes, and it's this 02. It's that last byte, that last value that determines the visibility of the sheet. So 02 is very hidden. 01 would be hidden, and we could just change this to 00. Save the document. I'll probably save it as something different. Um, Demo 2 XLSX unhidden. I'll replace it, sure. That way I have the original, just in case I mess something up. And I'll run that same command. The only thing we'll change this time around is the file that we're investigating. So unhidden.bin, the extension, the file name I just saved it as. And now you can see the visibility of our sheet has changed to visible. And if we go, I've already copied that document over to Windows. We can open this up. And here's our worksheet. Now this is again kind of an interesting one, just based off of the type of functionality that you find here, and that it has. And this is all in the exercise. So if you really want to dig into it, if you're interested, there it's hopefully again a good walkthrough there. You have these formulas that are first concatenating these values from these other columns. It's you can see as we highlight each formula, it's highlighting the corresponding cell. Now notice, let's see if I can get to one here. You'll notice that with these cells, it's skipping a few. So we have this first cell, so G1, G2, and then it skips G3, and then G4, G5, and then it skips G10. And so if we were to just dump this, say, you notice that we ran into a slight problem with our XLM deobfuscator. It didn't actually get to the point. Let's just go back and run that again. Oops. Demo 02 XLS. We'll even look at the unhidden one. No, maybe it did. There's our URL. Let me take a look at the other one. Oh, yeah, there it is too. So, anyways, I believe a year ago, or whenever I actually created that original exercise, it errored out, or there was a problem processing before it got to this point. So the idea was, well, if the tool isn't quite working at this moment in time, and we really want to get to a point where we can find the URL that it's downloading the next stage from, what can we do to work around that? Well, now it is. So now we really don't have this problem, but if it still wasn't recovering that for us, now we could come into the document. This one isn't quite so bad, but we could take this these column and we could just do the concatenation. So I don't have the internet enabled on that machine, so I'm going to keep bouncing around a little bit. Hopefully it's not too bad. And you'll see here, make this a little bit larger. I've already pasted. I just copied that column, pasted it into CyberChef, created a regular expression to parse out anything but the numeric values, and then use the from char code operation. Those are base 10 values. We can tell because they're not using the hexadecimal format. So from char code, making sure that we're base 10. You'll notice some things like I didn't account for when a line contains 2 chars. So here you can see that in my output down below. So a little sloppy, needs a little bit more work to clean it up, but now we have more reasonable output. So the two things that we'd have to clean up here in order to make this 100% correct would be just simply to make sure that these are on their own line. And we could do that with probably a find and replace as well. Anytime an ampersand was found, insert a new line, replace it with a new line, and just add that into the sequence in our recipe. And then we really do need to, if we want to again be 100% accurate, go back and identify those cells that aren't used in this concatenation. So let's look at this formula. Again, you can see the third this third value isn't used, it skips one. Otherwise, you're going to get these characters, whatever char 70 represents, you're just going to get that injected into that output. So you'll still probably visually be able to parse it just fine, but it is something to take note of. Yeah, David, I'm sure you did. It's probably I think you actually did it on the Cyber Defenders platform. I think you were tweeting about it as you were working on it. Okay, so that's again, the focus of that second document was just to look at the sheet visibility, and that it really shouldn't impact the tools. At least in my experience, it hasn't. But if we want to look at the content inside of our Office IDE, the Office suite, the Office developer tools, anything like that, we do need to, or we may have to modify that visibility. And one way to do that is to use the plugin BIF to get that information, and then a hex editor. Okay, the last one we'll look at today. Maybe I'm wrong. Maybe I will actually be under an hour today. So our last demo is one that I just went to. I don't know if I still have it pulled up. Yes, I do. I just went to the to Triage or Malware Bazaar, one of the two. I think I went to the Malware Bazaar first and just searched for a tag of XLS. Let's see if it's still in the search history here. Well, I'm pretty sure that's all I did, is searched for XLS docs, grabbed one of them that was a top result, and started analyzing it. So the tags for this one, now I'll go back. It was a tag with Cobalt Strike and XLSM and uploaded by Proxy Life. So thank you again for uploading and all of the contributions that you make. Found this one on Triage. So I was just curious before I started digging into it, maybe to get some heads up as to what to expect. So you can see with this process tree, and this actually will play a role with this document. We'll maybe go a little bit beyond just focusing on the macros and the maldoc, and get into a little bit more of what it does here. But you'll see that Excel launches an instance of command.exe. Here's our command line arguments. So it's using msbuild.exe with a few arguments here. That's just to quiet the output at the console. And it's taking the sync updater.log file. It's using that as input. Now, I've come across msbuild a number of times, but I've never had a reason or bothered to really dig into what it is. And so I haven't fully flushed that out. I didn't leave myself a whole lot of time this morning to do that. Quick searches show that it's part of Visual Studio. It allows you to give it basically a Visual Studio project, and then it will create or build it. So very similar, if you're familiar with Visual Studio, opening up a project, selecting build, and then all of the build things happen. You'll notice it also calls csc.exe. That's the C# compiler. CVS, CVTress, I didn't look that up, so I don't know what that is off the top of my head. At least if I did, I've already forgotten. And then finally, this C Windows System 32 sync appv publishing server.exe. That is also significant. You'll also notice that all of the paths here for the sequence of execution, it's all legitimate executables, right? MS Build is MS Build. It's installed as part of the Visual Studio, as well as these additional processes that the build and this build command is invoking, as well as, and again, this is going to be probably our most interesting process here. This is also found in C Windows System 32. Okay, so let's take a look at this document. Demo 3. Okay. Okay, so this document is not using Excel for macros. So there, as you'll see in just a minute, there is some content that is stored in the cells. So that's another usage for these Excel documents, is that instead of having all of the necessary resources, content strings, what have you, inside of the macro code or inside of a user form, it's going to store that inside the cell. And that's what this one is doing. Now, I didn't have an example for today, but there is, certainly documents I've come across that'll be VBA macros that then execute Excel 4 macros. So I guess you could consider that more of a hybrid approach. So a lot of options, a lot of different variations, combinations to get these macros to execute. Okay, we're interested then in the macros. So I just learned this the other day. All these years I've been dumping macros with OLE dump. I never once bothered to look at the docs and recognize that -SA dumps all of the macro streams. So thank you for the person that pointed that out to me through a YouTube content comment. Okay, so there we go. So -SA, if we didn't use all, we would just identify the stream index. Uppercase is the only one we really care about. The uppercase M indicates that it's a macro stream with macro code. So we could define A3, but I'll just say A to dump them all. And I'm going to redirect that to a file. So create this streams file. We'll open streams with Visual Studio Code. Already open, so let's go to the top just so we start kind of fresh here. Syntax highlighting. Usually Visual Studio Code is pretty good at syntax highlighting. If for any reason it doesn't recognize this as Visual Basic, I would encourage you to select whatever file format it detected down here in the lower right, and then type in Visual Basic. So you kind of force it to do that. Now, there's a number of things that are interesting in this particular set of macros. The first one is that we have direct usage of the Windows API. So it is possible. I was really surprised the first time I encountered a document that did this. It's possible that through the macro code, it can use any of the Windows API. So as you can see here, we have get proc address from kernel 32 and load library from kernel 32 and virtual protect and all of these others that are defined here and likely possibly used. In this particular document, they are. It doesn't necessarily mean that just because they're declared here up above that they are in fact used. There's a byte swapper function. So you'll notice that for whatever reasons, this particular, whoever put this document together, wherever it came from, they're using the legitimate name from what they're trying to import. Actually, I think that's how they have to do it. There is a way to alias these. Yeah, like this. So you can see this byte swapper is actually aliased. So it doesn't represent, I mean, it's an alias to the API that it's calling. So it's just easier if we need to find where get proc address is, we can now just search for it in code. If we need to find where RTL fill memory is, we have to look for byte swapper. Again, it's still fairly straightforward here. The naming convention, oftentimes, the obfuscation will be a little bit harder. The names will be much more nonsensical. So you'll just have to be able to, either do a find replace or just keep it straight in your head as to what represents what. Now, with this document, there's quite a bit here. There's some structures that will be relevant. A structure for process information, a structure for startup information. Structures are just a chunk of memory that in this case has members. Members help then to define what each smaller portion of this overall memory space for this object are. So we've got as a first member, CB is along. I don't know what CB is off the top of my head, but these are structures that are going to be used with some of these, as you can see here, with some of the Windows API calls. And so most of these you'll probably find documented on the Microsoft Developer Network or MSDN. We could visually just sort of inspect and look. Something might jump out that's interesting. Of course, if we go far enough, you'll notice that we come to a command. There's sync updater.log. That was a relevant artifact from our viewing the analysis and triage. And then we have our command here as well. And so we could maybe focus in on this area. We might want to find the entry point though. And for this demonstration, we'll do that. This one doesn't appear to use an auto open or an auto close. It looks like it's waiting for a button click. So, definitely seen as a technique that requires a little bit more interaction from the user. So they have to click something in order for the sequence of events, the Mac, to enable content and click a button in order for things to unravel here. This will eventually call OV. And I'm just going to do a find that. OV then has just simple determination on whether we're on a 64-bit or a 32-bit system. So you can make that determination here. It doesn't really matter. So we'll just go down the 64-bit path. So function called OX64, and here it is. And this is a bit interesting. I've heard of the technique before, certainly aware of it. Never again, I just haven't had a chance to really dig into it before today. Quick search. I'll put a link up. This seems like this was a pretty good write up for this technique. And essentially, what it's doing is there's the anti malware scan interface, or AMSI, and that can be used to check for things like buffers and other kind of significant events that happen within this document, to look for malware, and then if it is, to block it and to classify it as such. And so essentially what this function is doing, and there's one for 64-bit systems, there's another for 32-bit systems, is it's going to use this LDL, that's get proc address and load library. I think that's defined right here. There's load library, there's get proc address. So what it's doing is it's essentially looking for this function, loading this function, AMSI UAC initialize, and then that byte swapper that we saw earlier, RTL move memory, it's from the address that it resolved for that function, it's just replacing the first 2 bytes with a hex 90, which is a NOP, a no operation instruction, and a hex C3, which is a return. So it's basically patching that function so that when it gets called, if it gets called, it's just immediately returning. It's not going to do anything. It's not going to be able to perform. And again, I'm not 100% sure all of the activity that takes place from the AMSI interface, but it's not going to do any of that. So it's an attempt to make the document not show up as malicious. So those are the 2 paths there. Both of them. So the architecture will determine pointer size and things like that. So that's why there's a difference. Both of them, though, will eventually call AFRE. And if we scroll down to where AFRE is called, that's back to where we saw that command. So this, of course, is as we're unraveling this, we can identify some anti-analysis that could be very important. We then also identify how it's moving on to the next stage. I mentioned before we started digging into this one that it's going to use cells in those worksheets. And here you can see the cell command, row 100, column 3, row 100, column 4. It's grabbing values from those cells and storing them into these local variables. So let's just take a look at those cells. Okay. There we go. Oh, sometimes that stuff gets in the way. So that image was just causing me issues. So I just selected it, clicked on a cell that wasn't in the row that I wanted, and deleted it. Now you can see up above in the formula bar, right, there's definitely a bunch of content. And most of it looks to be, first glance, I would say base 64. We will confirm that in a moment. And then there's this last little bit of data with this project tools version. And again, that wasn't something that I've spent a lot of time looking at. So that was part of the overall structure that defines this project that can be handed off to that MS build process that we saw a little bit earlier. Okay, so we've got all those cell values, and you'll notice that the next sequence of events here is to get that content into that file, into that syncupdater.log file. So it's going to identify the location for the current user using their environment variables for the app data folder, create the file syncupdater.log, and then open that file and write all of that content out. So this $1 just represents a handle to that file once it's been opened. Also find the data in the shared strings. Okay. not sure I know how to open the shared strings. So maybe you'll have to send me a message and let me know. Um, because I did think about that earlier, where what is the best way to get that content out? And I'm going to take the easy route here in just a moment. Notice though, we've the order that it's doing that is printing this content. So it doesn't just follow the order of the columns. 1, 2, 3, 4, 5. It's doing it in a different order, and then closing the file. The last thing we'll see here is then our command is created. There's our result. That's the path to the file that was just written to, and then a call to create process. So another usage of the Windows API to create that process. So the second argument for that, and again, if you're not familiar with these APIs, with these function calls, create process you'll certainly find on the Microsoft Developer Network. So you'll be able to do a search, MSDN, Microsoft Developer Network, and then create process. So that executes that. So we'll take a look at that file just a moment. You'll notice that this also looks like it attempts to attain a little bit of persistence, and that again, we're expanding environment strings, and then it is creating an entry, that command, writing it as a bat file in the user startup folder. So the idea being that every time the user logs in, it runs that command and execution will attempt to occur. So what about this next stage? David just mentioned that you can find the data in the shared strings. Maybe I know where that is, but I was just not ringing any bells. So what I ended up doing, because I just wanted to grab that content, is I just downloaded it since I already was in Triage. So Triage and a lot of sandboxes, they'll capture all the artifacts as they're being dumped, and we can download that. So that's all I did. This makes sure, because it's going to grab the file as it's been written to disk, that it was now written in the order that I would expect it to be in, that it was arranged in those macros. We might be able to dump the strings, and you still might have to then arrange it in the proper order. We do have we can also what am I trying to say here? We have we have the Office Suite as well, and I didn't try to debug this, but it has just standard macros. My developer tab's all grayed out, but we should be able to also come in here and use that. Although again, I didn't try it, so there might be a couple of quirks here that I'm not anticipating with getting this to actually work. There we go. So there's our project, and we could go through. Oh, it's unviewable. Okay, so with that visibility setting, again, there's a number of things you can do to change that. Probably the quickest and easiest that I can think of is just there's a project called Evil Clippy. It's on GitHub. It's was made by Outflank. So you can go there, and they'll give you a little binary that you can use to change the visibility of the project. You could probably modify the hex and the binary of the file. I don't think I've ever bothered with that. I think Evil Clippy is what I've used. So, and again, I didn't try it, so maybe there's a few other quirks along the way, but it should get you pretty close. What about that file? So here's our updater.log.bin. You can see again, this was downloaded from Triage, so everything is in the proper order. And again, full disclosure, this is the first time I've actually looked at one of these, so I might have some of my first glance analysis a bit wrong. What I've come to understand, though, is with these build tasks, what you can do with these build projects, what you can do is you can identify tasks that can be executed as the project's being built. So it's creating this task, calling program main. Program main contains this string, which you can see with the mini view here on the side is large. So it's probably a PE file based off of the length and, of course, the context that we're in. There's the end of that string. So what's happening now is there is, in fact, our from base 64. That's just being stored into a byte array. And now here's the path to that sync app vpublishing server.exe. So we saw that back in our triage analysis. So here it is. Okay, what this is doing then is, again, using create process, but it's starting that process in a suspended state. And then we have an allocation. So virtual alloc ex allows the the program to get a handle of another process and allocate memory in that process. So this attempts to allocate memory there, stores the result in this result pointer variable. We have a write process memory. That's the location where we're going to write. That's the buffer that we're going to write from, and then the length. So there's our byte array from our base 64 decoded value up above. That's just the handle to the process. We then open this thread. Let's see here. Setting the thread context. Where did that get set? Process information. I don't remember what that does off the top of my head, but we then eventually call virtual protect, execute read write. Again, this is another one I haven't spent a lot of time looking into Q user APC, but we have the handle to our thread and the location of our where this code was now staged in memory before resume thread. So if I were to continue this analysis, it looks like they've loaded this executable content, a PE file, a DLL, whatever it happens to be, into memory and executed it. So now we could decode this and kind of continue the analysis here. But calling MS build and hooking into that build event by defining this task at the beginning of the project appears to allow this whole next stage to continue to unravel. And then we've got the functionality here. What is this really trying to accomplish next? It's in this section of code. Okay. Let's see. I think that's all I have for today. I don't have any other links that I missed. So if anyone has any questions, please feel free to drop those in chat. I'll hang on the line here for a minute or two and just see if anybody does. Appreciate everyone who joined. I know it's Friday. It's heading into the weekend. I had one of those weeks. I had to move my normal. I've been trying to get consistent and having these sessions Thursdays at 1. So I had to move that this week to Friday just due to some conflicts that I had yesterday. So appreciate everyone who was able to make it. I don't have the next live session scheduled, planning next Thursday, but I've got a few things on my calendar I'm just not sure I can dodge. So stay tuned. The following 2 weeks, though, after the next, I'll be out for a little bit of vacation. So I won't be online through the rest of May and then coming back that first week of June. So pick right back up when I get back, and maybe I'll get a few videos recorded before I go and publish those. If you have any comments, anything at all, again, please feel free to reach out, through this video direct, through social media, and I'd love to hear from you. Other than that, I hope everyone has a great weekend. Great, thank you. Yes, I really appreciate the feedback and all the support. It really is fun to do these, and it's fun to be able to share knowledge and talk about all of the different analysis that we can run across. There's a baseline of things you can expect, stages and obfuscation, but there's so many variations and nuances. Yes, thanks for joining, everyone. Thanks for joining, David. Yeah, look at that. Well under an hour. Ooh, that's some sort of a record for me. Okay, I'm going to wrap it up then. See you all the next stream.